Lesson 6.5 is on understanding congruent figures. So first of all, we need to know what congruent means. Page 326 gives us a definition of that. So congruent figures have the same size and shape. And there's a symbol here for congruent. It looks like an equal sign with a little squiggly line over the top of it. Okay? So same size and shape as each other, then they are congruent. So they give an example here in your book. They took it says she wants to place a flame-resistant hearth rug in front of the fireplace that's the same size and shape as the rug in front of the sofa. How can she determine whether the rugs are the same size and shape? So she took that, and basically if you move it over to the side and then turn it a little bit, then it matches up. This would be something with tracing paper you could use. Tracing paper, trace one of these and then move it over the other one and see if they work, if they match up exactly or not. Okay, but again, this is what congruent means. So example 2 asks they want us to see if these quadrilaterals is congruent. So the first step they said we could reflect ABCD across the line x equals -1. And then translate it 3 to the right and 2 down. They're trying to do some just reflect it across and try to get them directly on top of the other one to y-axis rather. So they said let's move it 3 to the left. I'm not sure why they 3 to the right and 2 down. And then maybe just to reflect it across x equals -1. And then translate it 3 to the right. The other option here, if we had tracing paper, or if we had paper that was clear enough that we could see through, your other option would be just to draw this original figure, and then obviously it would have to be flipped over. You could flip over your tracing paper and then move it and see if it matches exactly with that other quadrilateral. So after we reflect, that's what it looks like, and then we can move it down and see that it does look the same as the other one, so they would be congruent. So part B, they're asking if these triangles are congruent. One thing you can do with triangles is you can kind of box them in, make rectangles around them, and look at the dimensions of those rectangles. So if we box in triangle ABC, we've got 2 squares going one direction, 4 squares going the other direction. If we box in JKL, we have a 2 by 3 rectangle. So there's no way those are going to be the same size as each other, so they cannot be congruent. Okay? Again, you could trace it and try to rotate it, flip it, anything that you can do, but the ABC is just a bigger triangle than JKL, so that's not going to be congruent on that one. Okay, so the try it asks if these figures are congruent. So if you want to just trace one or the other of these, it doesn't matter which one you trace. And then we can just, well, you can try to turn it first and see if it matches up. That doesn't look like that works, so we can try flipping that. And my drawing might be off just slightly here, might be the problem, but those actually are congruent. The rectangles, like we talked about on example 2 part B, drawing a rectangle around a figure, technically we can only do this with triangles. There's reasons why, because the deal is with something like this, the angles and things might not be the same. With the triangles, we don't have quite so much variables to work with that we're allowed to do it with those. So if we look at the do you know how number 4, rectangle with an area of 25 square centimeters is rotated and reflected in the coordinate plane. What will be the area of the resulting image? And it would actually also be 25 square centimeters because we just rotated it and reflected it. It's still going to be the same size, and so it's going to still have the same area. Okay? If we look at the next part, they're asking if ABC is congruent to DEF. So if you want to trace ABC, and then you can try to rotate it, flip it, whatever you need to do. It does look like we're going to have to maybe reflect this one to get it to match up. So we reflect that and then try to move it over on top of the other one, and that looks like that's perfect. This one technically we could probably get by also with making that rectangle. So we've got a 2 by 4 rectangle, and then this would also be a 2 by 4 rectangle. Okay, it's at least, if nothing else, making those rectangles. I mean, sometimes you can just, by making the rectangles, automatically just say, well, the rectangles don't match, so there's no way that it's even going to work. If that's quicker for you to do than to trace it on the tracing paper and stuff, that could be a starting point anyway. So is it congruent? Then we would say yes. I mean, explaining, you could basically just say they're the same size and shape. The book actually talks about how we get from one to the other. So they said we could reflect ABC across the line x equals 5 and translate it 5 units up. Okay. For my purposes, you guys don't have to tell exactly your steps of getting there. You can use the tracing paper and things to figure that out. Then for number 6, they're wanting us to compare triangle ABC and GHI. And that one, I mean, just visually, you might be kind of able to tell about that one. But if you just make a rectangle, that's going to be a 5 by 2 instead of a 4 by 2 rectangle, so that one's not going to work. So we'd say no. You could just say that GHI is a bigger triangle than ABC.